Today and tomorrow we're going to review all of the things that we've been doing for quite some time that will be on Friday's unit tests, like simplifying algebraic expressions and using the distributive property and factoring out the GCF and adding, subtracting, multiplying, dividing, integers, decimals, and fractions. So let's quickly kind of go through some of these things that I'm talking about. So background knowledge. This is one big set of standards that we spent a long time on. It basically means adding, subtracting, multiplying, dividing, positive and negative decimals, positive and negative fractions, and integers. All of those things. And I still, to this day, put them on the homework every single day. I don't think today that we even need to talk about that because we should be very good at those things. But there will be a few of those types of problems on Friday's quiz. Okay? All right. There will be some of those on today's homework. Also, here's another big block of standards that we have talked about. Adding and subtracting, that means combining like terms. Factoring out the GCF, expanding linear expressions, that means the distributive property. So right there means the distributive property. Factoring means factoring out the GCF, and you may have forgotten what that means, but once I show you a problem, you'll remember quickly what that is. With rational coefficients, that means the numbers in front of the variables could be decimals or fractions. All right, that's also part of what we're dealing with today. Another big block of standards is solving two-step and multi-step equations and word problems that lead to those equations. We've done lots of that. Our focus on that will be in tomorrow's review. And then two-step inequalities and also word problems that lead to two-step inequalities. We will focus on that tomorrow as well. So let's just go ahead and get started. Does this kind of problem look familiar to you, yes or no? Yes. Quickly, turn to your shoulder partner, spend about 20 seconds talking about what you would do to simplify that. What I heard, and what you should have talked about, was the idea of gathering like terms together. That would be negative 5w. I did not ask you to simplify it, but if I did, this is what you would do. Something like that. Okay? All right. Number 2, I would like you to simplify this one. Go ahead and simplify 1/2 x minus 2/3 plus 2/3 x plus 4/5. We want to gather our like terms together. We have 1/2 x, which is a positive 1/2 x, and a positive 2/3 x. We would need to find the common denominator and do all of that stuff. But I believe that that is 7/6x. Some of you wrote it as 1 1/6 x instead. Those are equivalent to each other. And when we're writing expressions, it is okay to write it as an improper fraction. Then we have these constants. A couple of you took the 2/3 without the sign. That is a negative 2/3 and a positive 4/5. You would need to find a common denominator. And I believe that that is a positive 2/15. And so you could have either 7/6x plus 2/15 or 1 1/6 x plus 2/15. Any questions with that problem? All right, let's do the same thing with number 3. Everybody simplified number 3. And I'm focusing on the fraction ones and the decimal ones because those were the ones that seemed to be the biggest issue. All right, so this one, we would need to gather our positive 1.8n and our negative 1.2n. That is a positive 0.6n. And then gather our positive 7.12 and our positive 5. Remember, that is 7.12 plus 5.00, which is positive 12.12. So that is the adding and subtracting of expressions with rational coefficients. Next, we jump to the part of that standard that deals with expanding linear expressions, which is a fancy way of saying simplify using the distributive property. So I would like all of you to do number 4, 5, and 6. Please do all 3 of them. In this problem, the issue was not this times this for some of you. It was this part right here, and that's the exact reason why this problem is in here. So the question is this subtract 32 or plus 32? It's plus. And the main reason is because this is really a negative 4 that we are multiplying by a negative 8. And if you don't see that it's a negative 8, then add the opposite, and you will clearly see that that really is a negative 8. That's why it is negative 12a plus 32 and not subtract 32. So don't forget that. All right, number 5. Here we had 2/3 times 6h, and if you can't do that in your head, then maybe do that off to the side. You should see then that that is a 4h. And now 2/3 times 12, and much like the first part, if you can't do that in your head, do that multiplication off to the side, and that is 8. And I did see most of you get 4h minus 8 for that one. All right, and then number 6. Help me out here. What's 3.4 times 5m?
17.
All right, good. Help me out for the second part. What is 3.4 times 1.2? 4.08, correct?
Yeah.
So that simplifies to 17m plus 4.08. Any questions on the idea of expanding linear expressions? In other words, distributive property? Yes. That's the same thing. Those are equivalent to each other, yes. All right, let's go to the back side of the notes. And I would like everybody to do number 7. Now, number 7 is where we would need to use the distributive property twice and then combine like terms. So here's what we should be doing. Oops, I didn't mean to do that. Go backwards here. We should be multiplying that times that. That's 15x. And then this times this, that's minus 12. Did you get that? And then this times this is a positive 0.5x. Yes? And then this times this is a positive 10. Correct?
Oh, I multiplied 5 and 4.
Okay. Well, from there, we just need to gather our like terms. Positive 15x, positive 0.5x, that's positive 15.5x. And then we have essentially a negative 12 here, and a positive 10, that is a negative 2. So 15.5x minus 2. Okay? Any questions with number 7? All right, now number 8. I'm not going to have you do that one, but let's talk for a second with our shoulder partner about what we would do or what we could do if we were asked to simplify that. You have about 30 seconds with your shoulder partner. Okay, so, well, just 0.5, right? So what is 0.5? So what Chris is saying, this is what he would do. He would change the 0.5 to 1/2 because 0.5 is equivalent to 1/2. What's another thing that you could do instead of doing that? That's perfectly acceptable. What else could you do? Yeah, instead you could change these fractions to decimals, 0.5 and 0.25, and then do it that way. You would end up with two things that should be equivalent to each other if you do your math correctly. Okay, now we have a word problem form of one of these types of problems. So I want everybody to take a look at the first sentence. And if you think about this, that first sentence looks similar to some other types of word problems that we've seen. Sue earns $15.95 per hour. We're going to use H for hour, plus a $100 bonus. Does anybody know what I could represent as far as an expression goes for that? Yes.
15.95 H plus 100.
Exactly. In those two-step word problems that we've done. Now, how about that second sentence? What could we do?
If you put 8.50x, I mean 8.50h plus 100.
All right, and then what am I supposed to do with these two things? Well, it says if they combine their incomes, combining something, if you combine money in your left pocket to money in your right-hand pocket, you would be adding those two things together. So from there, we would just add those two expressions together. Everybody see that?
Yeah.
Okay, I'm not going to make you do that because I think it's obvious. We've done enough of those problems already today that I don't need to make you do that. But you would combine your like terms and simplify it from there. All right, so that's the EE1 standard. Let's now go to another part of that EE1 standard where we are factoring. Now, I guess I need to ask if anybody remembers how to do this, because it's been a while since I put one of these in the homework. Stefan?
You have to find the greatest common factor.
Okay, so what is the greatest common factor here? It's 4. So remember, essentially what we're doing, if we want to think of it this way, is we are trying to create a distributive property problem where the GCF is on the outside. So if 4 is on the outside, what's going to go right here? Just say it.
8.
W. What's going to go right here?
1. Negative 1.
It's, well, we already had the negative there. So it is 4 times the quantity of 8W minus 1. All right. I would like everybody to try number 11. It has 3 terms, but it works exactly the same way. So the GCF between all 3 of these things is 3. So it's 3 times the quantity of 2A plus 3B minus 5C. And remember, I've talked about the fact that you should take a quick look and make sure that these things have nothing in common, and they don't. And then you should mentally, in your head, multiply it out using the distributive property just to make sure that it ends up being this, and it is in this case. So our last problem for today is just one of these problems in word problem form. So it says an architect is designing a rectangular fountain for the city park. Its area is represented by 16x minus 40. Factor this binomial, and you can kind of stop right there because it's just asking us to factor that right there. So go ahead and factor 16x minus 14. So Lizzie, what does this factor into?
8 times the quantity x.
Oops.
8 times the quantity 2x minus 5.
8 times the quantity, 2x minus 5. Very good. All right, we are finished for today. Tomorrow we will review the second half of the things or the topics that will be on Friday's test.